Assalamualaikum, my name is Ahmad Shazwan with SS Mustaba with number matric B0117100076 from Faculty of Electrical Engineering. Today I will present about my final year's project, parameter estimation of electro-hydraulic actuator system that's supervised by Professor Madya Dr. Rozaini bin Ghazali, and I will present to board of panel Dr. Hairil Anwar bin Kasdirin and Madam Narkaslinda binti Hasim. Here the outline content consists introduction, problem statement, objective, scope and limitation, literature review, methodology, result and discussion, and conclusion. Next. Here we go to introduction. The regulate equipment required for higher power level while creating a signal processing mix with hydraulic servo are called electro-hydraulic actuator. Electro-hydraulic actuator usually used in motion control to determine the position, route, direction based on the steady response characteristic, positioning, and height level ability. There is figure for improvement of electro-hydraulic actuator in past decade. Then the problem statement of electro-hydraulic actuator is naturally have a load coefficient, high degree non-linearity, and modeling that make impossible to obtain effective estimation. And it also cause the performance that are uncertainty make simulation become more complicated. Next is objective. The main objective is to identify the transfer function of electro-hydraulic actuator system. The next objective of present study is to identify the mathematical model of electro-hydraulic actuator system using system identification toolbox, leveler work, estimation algorithm of model for parameter estimation of AHA system, and evaluate the performance of the estimate model and AHA model under different operation conditions together. Next is scope and limitation. There are several scope and limitations to achieve the objective. First, the model of electro-hydraulic actuator system is consists double-acting hydraulic cylinder with four-way directional valve. Second, syncate fluid model have been arrangement to create and identify the accurate model. And third, design the estimation model of electro-hydraulic actuator using system identification toolbox. Next, list of literature review that they refer in this project is research from 2040 IEE Conference on Control System by R. Ghazali, Y.M. Sam, and M.F. Rahmat. EHA have improvement in past decade in heavy industrial engineering is great for academic and engineering. Generally, mathematical model of EHA used to analyze its performance. Next, for the second research paper by Izzuddin Ahmad Atif, Muhammad Rizwan Johari, Khairudin Osman from 2050 IEE IRIS, the system model can achieve by two techniques, that is physical law modeling and system identification. The physical law modeling is required the knowledge about the system, so it's hard to apply, and the system identification just need only the input and output pair to obtain the system model, and it's very easy. The issue that cause dynamic behavior, HA, uncertainty, and other caused by actuators, friction, control valve, fluid compressibility, that cause the modeling of AHA become more complex. Next, The last research paper that they refer by T.G. Lane and Ahmad A.R. Hussain in Fourth International Conference on Mechatronics 2011, the modeling is important task and as a first step of analysis, the process to obtain the model is not easy. Next, the mathematical model of EHA can obtained by physical modeling or identification technique. Last, by using the system identification technique, we can create the many models such as ARX, steady space, and other. ARX is widely used to obtain the linear mathematical model of EHA and is very high precise among the other model. Next, this is flow of work of project. Start with problem statement, literature review, methodology, and next we go to rearrange and adjust the parameter of EHA model. As we can see in process and figure above right, arrange and adjustment of parameter, we can see the model is consist double acting cylinder and 4-wave valve, displacement pump and other. After we arrange and adjust the parameter, we run the simulation. This is our open loop simulation by using the multi-sine waves. Then after we run, we log the data from the scope to workspace and define the input and output data from workspace in data result HYD. Then we define the output and input in command window we call identification toolbox. Next, after we call the identification toolbox, first step is import time domain where we need to fill all the information, data format, workspace variable, data information, and then we import the data. We go to the step 2, pre-processing data using the quick start of HA model, and then step 3, estimate data of HA model using the quick start also. Next, quick start in system identification toolbox. Processing using quick start. As a pre-processing shortcut using quick start for the time domain data to perform the following action at the same time, which is subtract the mean value of each channel, split data into two parts. First part is specified as estimate data, which is working data, and second part is specified as validation data for model. For the estimate using quick start is following for three types of model following which generally named impulse, IMP, static space model, and 4F1 and ARX model. Next, process of system identification. Pre-processing using quick start to get model estimation and validation in data view. There are three available data plot, which is time plot, data spectra, and frequency function. For the time plot, only show time domain that contain time domain input and output. For the data spectra, plot show a spectral estimate of data in time domain. Its smooth spectrum calculate using frequency resolution. And for the frequency function, it shows the ratio of output to input data. Then we see the estimate model structure using quick start. As we explained before, there is three types: ARX, static space model, and impulse models. This is our selected model, which is ARX model. Next, result and discussion. By testing the enrichment of VHA model with some value of constant, which is 0.05, 1 watt, and 10 watt, we can see how the position root displacement respond. Next, output for different value of constant. As you can see in the graph, VHA model is quick and smooth response characteristic, where the biggest value of constant, the highest and the fast the root will moving. Next, testing HA model with multi-sine wave is choose as input supplies with different frequency, which is 0.5 Hz, 1 Hz, and 2 Hz. In order to capture dynamic characteristic of VHA system, this signal is preferred than original sinus signal. This is input and output graph, as we can see in the right. Next, this is VHA model output for input versus slot position that have been used as data collection that represent as result HYD in workspace. Next, we plot the data for input and output. After we plot, we define the variable input and output. Next, this is our final testing for estimation model and EHA model with multi-sine wave. This estimation model ARXQSPSM of EHA system has been created by using system identification toolbox. As we can see, the testing have been done to see the comparison of dynamic behavior of EHA model and estimate model. At the right, we can see how the supply signal. Next is output of both model. As we can see at the left, the output of EHA model, when we run, it perform 0.0000203 meter displacement, and at the right, the scope of estimate model, when we run, we can see the position root displacement is 0.0093 meter. Next, this is comparison output of both model. As we can see, the response of estimate model is close to actual response HA model with base fitting percentage 93.87%. The estimate model base fitting doesn't reach 100 due to non-linearity of system, which is linear model are unable to model. At the right, we can see the estimate model transfer function of ARX model, which is discrete time transfer function. As you can show below, that's all. We go to the next slide. Conclusion. Not linear HA model can be modeled using simple fluid model with linear model approximation. The system identification doesn't have user to know a pure knowledge about the system to obtain the estimate model. And however, the control system and real system slightly different in transit response and steady state response because of nonlinearity and uncertainty. For the future research, we can focus on designing adaptive controller, which is PID, fuzzy logic, or other, to achieve a better response using Simscape float. That's all from me. Thank you.